analysis. So this application is used for scaffold scripting matched molecule pair analysis platform. So in this to run in this platform, first you need a activity file. So first you have to create the activity file. So the activity file should be in this format. Okay. So this file should have these following fields. So this is JSON files was the compound chemical ID and target name and its standard type. So activity standard type and the standard value and the standard units, and then the standard relations, what's the relations and the confidence score, then the canonical SMILES. Okay. So you should generate this kind of JSON files. Then you have to upload the file into the matched molecule, the pair analysis platform. So you have to browse your file. So I have saved my work, and this is that MMP analysis. Okay, so here the file. So now I have loaded my file. Next, first I want analysis MMP analysis. Just I click the MMP analysis. So now it is running the MMP analysis. Created that results. So okay, so now we will see this 289 unique codes, and this is 200 and 2180 unique transformation and 2830 total mmp pairs. So this is our this is list all the unique structures. So we can see all the unique structures, and suppose if you want to see in the 3D also possible. So if you want to see in the view 3D, so it will give that 3D, and you can also rotate this one also. Okay. So this way you can view the 3D, and then 3D parts. Okay, so in the 3D parts you can see, so this is that structure, and this uh, orange colored molecule is that this molecule is in. Okay, so this is the splitted molecule. Okay, so what is the effect of this molecule and everything you can see in the chart. And this is the here this molecule is out. Okay, so here this molecule is in. Okay, this way this entire application has been generated. We will see application overview. What does MMPA analysis do? So MMPA analysis will do two things. One is SAR split, another one is MMPA analysis. In the SAR split, we can extract Bemis-Murcko scaffolds from each molecules, group compounds by shared scaffolds, show scaffold level transformations, and handle salt mixture smells automatically. And for MMPA analysis, perform matched molecular pair fragmentation using RDKit and rdMMPA, find conserved course and fragment changes between related compounds, and summarize transformation and pairwise activity also changes. Also, del IC15, del molecular weight, aggregate statics across the transformation types. So okay, so this is the mmp analysis and SAR split and mmp analysis. Okay, so this is a flag based web application designed for a medical chemist. Upload a JSON compound dataset to analyze structure activity less one. Two these powerful modes, one is SAR split, another one is mmp analysis. Next, the front end. So front end, we can upload the JSON. This is system architecture. We can upload the JSON and trigger the analysis and view result tables. Then 3D viewer, you can use the 3D mode JS. Okay. So same thing. The backend we have to use that upload and that run as split or run our MMPA and API slash mole images and API mole 3D. So this is a Flask. So we'll get the complete backend. So you can use any other front end application also. The chemistry core. So there's a different functions. We are using the different functions. One is run SAR split and run MMPA, mol to image B64, mol to 3D STF, and mol to 3D color things. So this is a system architect. So first we can the browser upload. First we have to upload the JSON file. Next we have to analysis that browser file. Then next the core processing, we have to process the entire thing. Then molecule API. So molecule API is calling. So it is creating that all images and everything. Then finally it will render the UI display. Third one is MMP analysis. So next, so SAS bit. So logic, we will deep dive in the logic. Okay, first we have to check the input. We are validating the input. Then we have to molecular parse. We have to parse the molecule. Then scaffold extract. We have to extract the scaffold. Then we will do a transformation. Then we will do aggregation. Then the entire result is written as a return. Okay, so so canonical SMILES and so these are the file format and standard value activity and the standard units and standard types and target name. Okay, so key processing rules: salt mixture handling and MMPA filter, fragment size limits, okay, and dummy atom cleanups and path duplication. And key files and how to run this as the files in this project. App.dat file is the main front-end file, and MMPA logic is handle all the logics and template and index HTML. It is the web page and templates, and that static JS, main JS is the front-end upload analysis, declare and result tables, and 3D viewer interactions. Everything's in the main.js. Next, static as CSS in the styles at CSS. It is a application styling CSS file. As JSON, this is a data file, so we have to create our data file. By using the data file, we can do the entire analysis. Then final one is a limitation and roadmap. Okay, there is no persistent storage is not defined, and there is no authentication. This is you can use your personal system and performance on large data. MMPA pairs and so this is if you use the more number of it, you will get that. The background work is very heavy and no pinned requirement, so there is no requirement text. So you have to implement so whatever the missing modules. So this is the entire and summary. So now we can do a scaffold analysis by using the MMPA analysis application. You can analyze a scaffold.